Hello and welcome. My name is Mac, and this is the third update for MLFX, September 2020 update. And we're going to be running through this relatively quickly. Just moved into my father's house and set everything up so I'm back in business after a bit of a haywire expedition from the Philippines back to New Zealand. But back safe now and ready to get back into things, writing some articles. I feel like I've been sort of towing the line a little bit, and Armory's been holding us above water, as you can probably gather from this article if you've read it. For those of you who prefer to watch the video, this is going to be, for you. And also we'll go a little bit more in depth on some of the things. I'll do a showcase. There's also some extra additional things that we've done because I am publishing this on the 10th of October. So we're a little bit later. And we're working on some really cool other stuff as well. Some of it's already implemented, so I'll give you a sneak peek as to some of those things as well. Right, so starting off, this article is written a little bit different than usual. Instead of kind of like breaking it up and segmenting it out, just done a bit of a chronology of events as to what happened, things we changed, and really it was our response to issues that we were facing every sort of week or every other week, or when we were trying to improve the system. What did we need to do? What was our thought process? So first things first, we started off with a Kmeans clustering algorithm, and that was to segment the Pareto frontier, Pareto, if we want to roll the R, frontier, which is as seen on the screen right now. It is kind of, it is like a curve of optimal solutions if you have multiple objectives. So we actually have 3 objectives, so you can't really visualize. We can visualize it on a graph, but it'd be super complicated. So this is just a lot easier for illustration with a 2 objective system with a Pareto frontier, where you see there's like a little bit of a curve where they're either really good at one and not good at the other, or sufficiently good at both of them. And then back to this swinging to the being good at one but pretty bad at the other. So the idea being that we would have almost an infinite number of agents on this Pareto frontier here, and then eventually it becomes too cumbersome for the system to go through all the number crunching and whatnot, and it starts slowing down. And what we noticed was that the system was crashing repeatedly. So we wanted to make sure we could set a fixed number of agents, and we found that 600 was the good number, right? So that's what we were going to aim for, 600 of these yellow circles here. And what it does is it clusters them together, then it vectorizes, which means turns it into a shape, basically, turns it into a vector, and then it would find the centroid of that vector, and it would find the agent closest to that centroid as the selected agent. So you can see, if you look really closely here, we might have to zoom in a little bit, but you can see there's actually some red agents in here, and they are not representative of where the centroid would be. Obviously you can see, on this one here, it is far right. It would always be towards the center of that cluster. So that would be the one way that we would make sure we would only have 600 agents, is that we would have a maximum of 600 clusters, and we would know that it would never exceed that threshold. We would still need to crunch some numbers with all of the other agents on there, but for the most part, the hard number crunching would only be done on those 600. So we had that sorted. While we were doing that, we also were working on a pattern recognition system, or I should say Armory was working on it. And this was really, it was sort of in conjunction with what we were doing here with the Kmeans clustering, sort of connected, but also it was, one of the main reasons was we identified that the previous system was essentially randomly selecting data. It was selecting the most recent 1,500 data points or so, which is, roughly, well, for us it would be 1,500 hours. Each hour signifies a data point. 1,500 hours, you're talking roughly 60 days or so, right? So 62.5, I think, to be more specific. So roughly 3 months or so of trading, given that there's about 2 days per week that you don't trade. And it would take that information, and then it would basically use the very most recent as testing, then the sort of middle data is optimization data or training data, and the oldest data is the creation data for creating the agents. So this is the process it goes through. It goes through the creation of the agents, which is basically, it knows everything that's happened. It's like you get the examination papers for the test before the actual test, and you can sort of read up on it. You know exactly what's going to be in there. You have a textbook with all the answers. You just got to do the swatting, the research, and then you can figure it out. So that's essentially what the creation data set is our system knows exactly what's happened. It knows exactly where all the price movements happened, and it can kind of fit agents into that. Then the second, the training data set, is basically, it kind of knows what's happened, and then it's basically optimizing those agents that were already created for this next data set. The previous issue we had was that we had no control over those data sets, and it could be a bullish data set that they were created for, and then a bearish data set that they would optimize for, which is contradicting. And you're going to get an agent that thinks it should be buying, trying to then convert to selling, and it just kind of mucks everything up. So the idea with the pattern recognition system, we can negate that, and we can ensure that agents that are created for a bullish market are optimized for a bullish market and tested in a bullish market. Therefore, we get more consistent results, and the agents are, reach their full potential, so to speak. So there's a couple of bullet points here. I think I've probably covered off all of them, but this image here is what it looks like now. Well, in the early stages, with the number of agents and stuff, this was an image that showed we have the AUD USD, bullish, bearish, stagnant. So the three different data sets there, or three different agent pools, I should say, and agents are getting added to them depending on, as the current system is working, it is testing the live market. It is using the same pattern recognition system to try and identify what the current market is, and then it is doing this optimization process and creating agents after it's tested the market. And I'll show you a log system that explains that a little bit better. That's actually not covered in this article. It's one of the things that came a little bit later, but it's really exciting. It's good for us to identify bugs, and it's just really cool. So we'll jump into that after this article. But the next step, which actually had to happen with these first two, was the database update. So an updated schema that enabled us to do many different things, including buffering, including batching of agents, including multi-threading capability, which we're not really utilizing as of now, but we definitely will be in the future. So it was really a precursor to many of the different changes that we are looking to make, and the necessary step at the foundation level. So not too much to really go into detail here. I'll read a little bit of a snippet from what Amory was talking to me about. We'll skip over this first bit here. So he said, I also changed how some of the functions work with the get agent function. Evaluate agents function now receives 10 agents out of the agent pool, evaluates those 10, keeps their results. So instead of having the group of 10 lists where the results with the results for those 10 agents, we'd keep the averages, sums, etc. for those 10 agents. Then we'd retrieve 10 more agents and do the same. That way we only keep 10 agents on memory at any time. We can work with thousands of agents stored in a pattern market time frame. For time frame, it's always 1 hour, which is what we train everything on at the moment. As you said, who knows, we could change this later, keep it flexible. So this allows us to have a technically unlimited number of agents, but we probably, as you said there, will put a limit on the agents, because if we have, say, 100,000 agents, the whole entire process is going to become too slow for us to function, and we want to be able to allocate our computation to other areas instead of just having a sheer massive number of agents when so many of them are probably very similar that it's almost indistinguishable, right? So as I said here, this means technically we don't need the Kmeans clustering algorithm that we created. However, it's good to have that on standby because, as he said here, we may want to cap it at some level anyway, and we can use it for other things. So it's good to have that all ready to go. The final sort of thing that sort of ties into what we were doing there was, funnily enough, after we did all of those improvements, which we thought would remedy the issue of having the server crash and having the agents take too long, it wound up that the time it was taking for the agents to produce a signal was actually increasing. It started off around about 20 minutes, and then it got to like 30, 40, 50, and in some cases up to 2 hours just for one agent to go through the full optimization process, do all of that, and spit out a result, or get to the next pairing, so they could churn out a result. So we know that we're going to separate this process at some time. We know we're going to use the multi-threading capability of the new database schema, and we're going to segment out the testing and the optimization process, so we can have optimization continuously cycling in the background and testing happening on a time-based schedule, because testing takes only milliseconds, right? Or a couple of seconds at best, at worst rather. So what we can then do is basically say, okay, every 5 minutes I want every single market to be tested, or every 10 minutes I want every single market to be tested. Then it allows us to cherry pick the signals a lot better. It allows us to focus on the signal labeling, right? So it could be a very, very strong buy, which is what we were previously doing. So it allows us to reintegrate that at a much better level. So it's more granularity, and we've done a lot more research to understand it more. And because we'd be regularly testing every 10 minutes, 5 minutes, we can then create an algorithm that would automatically be able to detect which of those trades are most likely to be successful trades. So it's not only just looking at, is this agent usually profitable, what's their win percentage, how much is their average revenue, all of that. It would be some other pattern recognition system in the background to add another layer of complexity if we didn't already need so. So what we found is that we are eventually going to do that. At the moment, it's not a super high priority, so we just made a quick fix, which is changing to time-based iterations. Previously, it was going through 50 iterations on a cycle, and as I said, depending on how many agents within each pool, it took longer and longer. So, as the agent pool grew, so did the time and duration between signals being given, and it made it very inconsistent, which neither of us liked. So we decided to switch from a 50-based iteration period to a time-based iteration system, which means that instead of using 50 iterations, we're now just using 7 minutes of iteration, or of optimization, 6.66 or something to be specific, because we divided an hour by 9, since we have 9 pairings. Then after that, one of my favorite things we've done so far, and I think this is going to be exceptional for marketing, also just for motivation, because we can immediately see if the improvements we're making are having an impact. And this is in the very early stages, but it is the automated win-loss checker. So instead of me going through and checking every single trade, as I've been doing for the last 6 months, I'm going to say at least 50,000 trades I've checked, probably in that order of magnitude. But it's great for learning. I feel like I've learned a lot by doing it. However, I feel like I'm probably not going to learn a heck of a lot more if I continue doing it. So it's good to have this system up and running so we can automatically check the trades. And this is what it looks like at the moment on the actual system on the right hand side. So we have it's set up to check the trades after 24 hours. So after the trade has been live for 24 hours, it will, after the most recent optimization process for that pairing, it will run through and it will check all of the trades to see if any of the sort of outstanding trades, I guess you'd call it, have hit their take profit or stop loss and been resulted. Then it will display either in green or red, depending if it was a win or a loss, what the result was. This is awesome. It's good to see. It also has drawn a light on the fact that there is some other issues that we're facing. One was what I was talking about earlier, which is the pattern recognition system that is dictating which agent pool to use and which agent pool it should draw the most activated agent from to trade. So we're looking to maybe tweak that for next week and see what the results are. But now that we've got 2 weeks of data, we can then compare the data from these changes to see, okay, definitely this is an improvement, or no, it's not really done much. Maybe it's done a little, right? So it just gives us that certainty that we know exactly what effect changes are having on the system. But yeah, as I said, really, really happy with that. It's super exciting to see and think about what we can do with it in the future as well, in terms of graphing stuff out, in terms of using, instead of PIP revenue, average percent return, those types of things. And and segmenting it out to individual pairings, different times of the day, different markets in terms of the New York market, London market, those types of things that we can and will do in the not too distant future. Next point, last point for the article is the unique agent IDs, which allows us to associate a whole bunch of different data with an agent and not worry about that unique agent ID being created again, because we're using what's called universally unique identifiers, and they have such a low probability of repeating the same identifier that it's almost negligible, right? It's pretty much zero. I think I read somewhere that the likelihood of it's more likely for a meteor to hit Earth in the next sort of 5 to 10 minutes than it is for us to get another one of these, and the likelihood of that happening is super low. So that should allow us to move forward with confidence. As I said, allows us to assign a whole bunch of different details and information to agents, also cross-reference with the analysis page right here. So we are going to create what's called a metrics page, which will individually list out every single agent, their performance in terms of average revenue, average return, average win streak, lose streak, numbers of wins, losses, total trades, a whole bunch of stuff, right? We want to go super in depth here because we're creating this system for us to use as well as you guys. It's not a one-way street. We want this system to use for ourselves. We both love trading and we want to trade full time as well as do this business. So that's really our motivation behind it, is just going super granular down to the foundation and looking at it from a first principles almost level and saying, okay, let's break this down into the smallest possible moving parts and then work on those moving parts to hopefully collectively bring it back together as something that is just, magnitudes better than what we previously had. And there's a bit of a little teaser down the bottom here of this article as to something that we're working on that does just that. And that is this bit here. It's the upgrading of the fuzzy system. So Amory's been working on some literally insane improvements to the fuzzy system. And he's got a bit of a snippet here. He said, we can store the agent's fuzzy system simply as a matrix-like system. And he's got some numbers and stuff. Honestly, to me, that doesn't make a lot of sense. But he said he also wants to store the agent's perception functions, so talk simple moving average, stochastic, RSI, and its parameters as a matrix, which will increase the speed significantly. Because I remember seeing that the bottlenecks, and that's him, Amory, remembers seeing that the bottlenecks were serializing and deserializing an agent's fuzzy system. So a little bit of a more of a teaser there is that we're not talking of, singular times improvement, so like 2 times improvement, 3 times improvement in terms of the actual computation ability or the speed of the system. We're not talking tens, we're not talking hundreds, we're not even talking thousands. We're talking hundreds of thousands of times better, which is just almost unfathomable. I really can't wrap my head around how something can go from, the way it is now to being hundreds of thousands of times faster than it was previously. And it's performing at a similar level. So think of it this way, right? What I was talking about earlier, we have iterations. Each iteration is basically a mutation of an agent. It is that agent going through the evolutionary process where it is looking for ways that it can optimize itself and become better. Now, with this new system, the old system for one iteration, in terms of it going through one complete cycle of mutation, in that same time, this new system can do that same process hundreds of thousands of times more. That's insane. That literally is so insane. But I won't go too much into more detail there. We will save that for next month's article and update, but I just wanted to give you a little bit of a teaser there. Finally, before finishing the video with a little bit of a look into the log, which is a new system we've created to help us with bug fixing and help us going through all that. So at the top here, we have the current agent pool. It's still relatively low in terms of the numbers. This new system allows us to integrate much more complex agents with many more rules, looking at a bunch of different data inputs as well, which will mean that we have more unique agents, and these numbers should go up. There's also other things we're looking into in terms of having more agent pools, or having the agent pools sort of segmented a little bit to increase the uniqueness of each agent, meaning that it shouldn't, in theory, get dominated by other agents as easily. And then what we go into, I actually scroll down and I'll find the beginning of the process, so it'll list. Once we get down here, there's a lot of data. So this here is a validation process. As I said, it's going through the last 24 hours. It's looking at the trade, seeing whether or not it's got a result. No result for most of these. There's a result for this one here, so that's a positive 45 pips. And there's one here, which is a negative, I think that's negative e to the 4, so on the fourth decimal, that would be negative 8 pips for that one. Then what it does after that is it goes into the next pairing, which is the USD CNH. It retrieves the rates, which is the data from Oanda, testing data sets created, creation data set, training data sets created, tells you which, where these data sets are coming from, how long they are. These are hours, right? Each hour is a data point, and how many agents it received from the pattern after it's determined which pattern it is, which is bullish. Then it's onto the signal, trying to create a signal with 34 agents, so it evaluates the agents. It figures out whether or not it trades at different points in this data, so it's looking at the different data points. A plus is for an agent that would have traded there. A dot is for a data point that would have had no trade. It does it twice, comes through, finishes the evaluation, the training process is successful, testing successful, spits out a prediction based on the most activated agent. Take profit here, you can see, is 35 pips because it's USD CNH pairing, 350 pips, sorry, and the stop loss is negative 104 pips. So we're looking for a positive move, and then it tries to create the trade, creates the trade, and we should be able to jump over to the signal and find USD CNH. Here we go, that's that trade there. Now, back to there. Then it goes into the optimization process, which is really just cycling through the iteration process that I was talking about, trying to find mutations of similar agents or create completely new, unique agents and see whether or not they can perform better using those data sets that it is just sort of sliced up, right? And that is us for this month's update. I really hope you enjoyed it. If you did, please consider subscribing to the channel. There'll be many more. And please leave a comment down below if you've got any questions about anything you want to see, any more updates. And the one thing that I'll just talk on before we finish is this little arrow here, which is indicating which agent pool this trade has come from. So arrow to the right is a stagnant market, arrow up is a bullish agent pool, arrow down is a bearish agent pool. And with that, I shall see you in next month's update. In fact, probably before, I'm going to do some videos throughout this month because the system's getting to the stage where it is now functional again and we can start trading with it. I'd like to do a couple of videos like that now that I have a desk set up with a computer, webcam, all of the good business that we need to do these. So I shall see you probably before next month's video.